Thevenin's theorem is used to solve complex circuits consisting of several sources and impedances by converting them into a simple equivalent circuit called Thevenin's equivalent circuit. So Thevenin's theorem can be used to solve both AC as well as DC electrical circuits. Okay. So here this is the statement of the Thevenin's theorem. So the Thevenin's theorem states that any linear network consisting of several sources and impedances can be replaced with a single circuit consisting of a voltage and a single impedance connected across a load. Okay, so this is the Thevenin's theorem. An electrical circuit may have a number of sources and a number of impedances, and there is a load here. So this entire electrical circuit can be replaced with a single voltage source, which is called as the Thevenin's voltage, and a single impedance called Thevenin's impedance. Then these two are connected across the load. So how to solve a circuit using Thevenin's theorem? So it involves three steps. Step 1 is to find Thevenin's voltage or Vth. So let us consider this is the given circuit. So in this circuit, to find the Thevenin's voltage, we have to remove the load resistor. This is the load resistor. We have to remove the load resistor. That is the first step. So if you remove the load resistor, you get a circuit like this. So here we have to find out the voltage across these 2 points A and B. So if you determine the voltage across these 2 points, you get the Thevenin's voltage. So this is the first step. The second step is to find the Thevenin's impedance. So to find the Thevenin's impedance, so this is the given circuit. So to find the Thevenin's impedance, you have to remove the load resistor, and if there is a voltage source in the circuit, then that should be removed with a short circuit, and if there is any current source, it should be removed and kept it open. So if you draw the resultant circuit, you get the resultant circuit as like this. So here there is a load resistor that is removed, okay, and here there is a voltage source. It is removed and replaced with a short circuit. Okay, so now we have to find out the Thevenin's impedance across these 2 points. So once you determined Vthevenin and Zthevenin, then we can draw the Thevenin's equivalent circuit, which is the third step. So Thevenin's equivalent circuit is simply drawn with the help of the Thevenin's voltage and Thevenin's impedance that are connected across the load impedance. Okay, so this is the process of determining the Thevenin's equivalent circuit. So from the Thevenin's equivalent circuit, it is very easy to determine the current through the load or voltage across the load. Now let us look at a problem. So here the problem is to solve the given circuit to find the current through 10 ohm using Thevenin's theorem. So here 10 ohm is considered as a load. So where is the 10 ohm? Here is the 10 ohm. So this is considered as the load, right? So we have to find the current through this load. And here in the circuit, 9 voltage is the voltage source given, and these are the resistance given in the circuit. So now let us solve this. First is you have to find the value of Vth. So this is the given circuit, right? So in the given circuit, this is the load resistor. To find the Vth, we have to remove the load resistor. So this is the circuit. So the load resistor here is removed, and we have to find the voltage at the points A and B. So when you observe the circuit, since here it is open, there will not be any current flowing through the 3 ohm resistor. So it is enough to find the voltage across the 3 ohm resistor. Since there is no current flow here, we have to determine the Thevenin's voltage across the 3 ohm resistor. Okay, so to determine the voltage across the 3 ohm resistor or the voltage drop across the 3 ohm resistor, we have to find the current through this path. So let us assume the current I in the loop. Now we have in this loop there is a voltage 9 voltage and there are resistances. So simply by applying Ohm's law we can able to find out the value of the current. So this 1 ohm and 3 ohm resistance are in series. Hence the total resistance will be equal to 1 plus 3 is equal to 4 ohm. So by applying Ohm's law, V is equal to IR or I is equal to V by R, we can able to find the value of the current. Here V is nothing but the voltage and R is nothing but the total resistance. If you substitute, we get 2.25 ampere. Okay, now we have obtained the current through the 3 ohm resistor. To determine the voltage across the 3 ohm resistor, which is nothing but the Thevenin's voltage, again apply the Ohm's law. So the voltage across the 3 ohm resistor is given by V is equal to IR. So I we have determined 2.25 ampere and R is nothing but the 3 ohm. So if you multiply both, you get the total voltage as 6.75 volt. So this is nothing but the Thevenin's voltage. So the first step is over. The second step is to find R Thevenin. So to find out the R Thevenin, here this is the load resistor. We have to remove the load resistor. And there is a single voltage source. We have to replace it with a short circuit. So if you redraw the circuit, you will obtain the circuit like this. So here we have removed the load resistor and here the voltage source is replaced with a short circuit. Okay. Now we have to determine the resistance across the 2 points A and B. So if you observe the circuit, this 1 and 3 ohm are in parallel with each other, right? So this parallel combination is in series with a 2 ohm resistor. So very simple, these two are in parallel and this is in series. So the equivalent resistance can be obtained as 2 plus 1 into 3 divided by 1 plus 3 is equal to 2.75 ohm. So we get the equivalent Thevenin's equivalent resistance as 2.75 ohm. So we have got Vthevenin and R Thevenin. Now the next step is to draw the Thevenin's equivalent circuit. So the Thevenin's equivalent circuit is drawn with the help of the Thevenin's voltage, which is we obtained just now, and R Thevenin, which is also we have obtained just now. So you have to draw this voltage source and the resistance, and those are connected across the given load in the circuit. So once this is done, we know all the values. So it is easy to find out the value of the load current. We know the voltage, we know the resistance by simply apply the Ohm's law. So IL is equal to V by R. V is nothing but 6.75 and R is nothing but the total resistance 10 plus 2.75. So if you divide both, you get 0.529 ampere. So this is the value of the load current. So this is how we have to solve a circuit using the Thevenin's theorem. Now let us look at another problem here. So in this problem, solve the given circuit to find the current through 15 ohm using Thevenin's theorem. So here 15 ohm, here there is a 15 ohm, right? So you need to find out the current flowing through this 15 ohm resistor. And in this circuit, there is a voltage source of 40 volt and there is a current source of 2 ampere. And these are internal resistances. Okay. So this is the load. This 15 ohm is the load here. So to find out the solution to the circuit, the first step is to find the value of Vth. Consider this given circuit. 15 ohm is the load resistor. To find the Vthevenin, we have to remove this load resistor. So if you remove that, we get this circuit. Now you have to obtain the voltage across the 2 points A and B. So to do that, it will be more convenient if you convert this current source into a voltage source. So we are applying the source transformation to this circuit. So here there is a current source connected in parallel with the 5 ohm resistance. So by source transformation, we can convert this current source into a voltage source where the voltage value is equal to V is equal to IR, that is equal to 2 into 5. Here this is a 2 ampere and here it is 5 ohm. So if you multiply both, you get 10 volt. So the circuit can be replaced like this. Here this current source can be replaced with this voltage source, and the resistance which is in parallel with the current source can be drawn as the resistance in series with the voltage source. So now we have to find out the voltage across the 2 points A, B, which is nothing but we need to find out the voltage across these 2 points. So let us assume the current I in the loop. Now by apply KVL in this loop to find out the value of current. So by applying KVL, so here I is the current and 20 is the resistance. So 20I plus here the voltage drop is 5I. Here it is 10 plus 10 and here it is minus 40 because here the polarity is changed. Here the polarity is plus to minus, whereas here the polarity is from minus to plus. So we add minus symbol here. So if you solve this, you get I is equal to 1.2 ampere. So we have obtained the current through this path as 1.2 ampere. Now to find the value of Vth across these 2 points, Vth is equal to, here we know already 10 volt is there, right? And here there is a 5 ohm. And here the drop will be is equal to 5 into the current which we determined. 5 into 1.2. So if you add both, you get 16 volt as the Thevenin's voltage. Okay. So first we have determined the Thevenin's voltage. Then the next is to find R Thevenin. So to find the R Thevenin, let us consider the given circuit. In the given circuit, 15 ohm is the load resistor. This load resistor has to be removed to find R Thevenin. Okay. And we have a voltage source which we have to remove and replace it with the short circuit. And then we have a current source here. So we have to remove the current source and we have to keep it open. Right. So after doing all this, if you redraw the circuit, you get a circuit like this. So in this circuit, here there is a load resistor which we have removed, and here there is a 40 voltage source which we have removed and placed as short circuit, and here there is a current source which we have removed and it is kept open. Okay, so this is the final circuit. Now in this circuit, we have to obtain the R Thevenin across the points A and B. Very simple. So if you observe this circuit, this 20 ohm and 5 ohm are in parallel, right? So are in parallel. So find out the equivalent resistance. R Thevenin is equal to 5 into 20 divided by 5 plus 20 is equal to 4 ohm. So this is the Thevenin's equivalent resistance. Now we have determined the Thevenin's voltage as well as the Thevenin's resistance. So the next step is to draw the Thevenin's equivalent circuit. So the Thevenin's equivalent circuit is drawn with Vthevenin and R Thevenin connected across the given load. We know all the values. So it is very easy to find out the value of the load current. Simple by applying Ohm's law. IL is equal to V by R. So V is nothing but the Thevenin's voltage and R is nothing but the total resistance, that is 4 plus 15. So Vthevenin by the total resistance, if you substitute, you will get the value of the total current 0.842 ampere.